All right. Excuse me. So you should be able to see the main class portal. You should hear me okay. If there's any troubles, let me know. I will be peeking at the chat window once in a while as I conduct this lecture, and we'll get through to the end. All right. So this is let's just see here. What do we have? We have our course plan, which is in the content. You can download this thing. Week 3. All right. We got 1, 2, 3 types of materials, and I'm going to make them available for your viewing today, which is basically the slides that I'm going to present. And we'll talk about cable types, service conductors, and portable cords this week. Part of it, of those 3, we're going to cover today online. And part of it, we're going to... and part of it we're going to the second part of it we're going to cover tomorrow in person. Okay, I get a signal that that the audio might not be coming through properly. Okay, all right, I guess we're good. That might be your end, Dale. All right, so let's see our roadmap here. We got our hand tools, and we're going to week 5, so the week after this. We're going to have our first squeeze. All right. All right. So last time we covered the multimeters. I think we should be sort of comfortable with using those multimeters. Of course, during the labs, just bring your multimeter, bring things that you want to measure. Because if you finish the lab earlier, you are most welcome to stay and explore more and more. I can always give you more things to do if you finish the lab earlier. Okay. There's no such thing as knowing too much about how to use the diagnostic equipment. All right, so today we're going to, well, you know what? We're going to start with this right here. We'll be talking about cables. So first, let's just take a quick look at the differences between a solid core wire and a stranded wire. I put together a little kind of a PDF presentation. All right, so this is what this is what the solid core wire looks like. It's basically a strain of copper, and it is jacketed with whatever jacketing is jacketing it. All right. Now, here is the equivalent of that, and that's what a stranded wire looks like. There are pros and cons to using either one of those, and we're going to take a look at some of the differences here. So, let's see descriptions, what the differences are. A solid core wire is a single strand core of wire insulated with non-conductive material. Of course, we need to separate the copper from other copper conductors so they don't touch. And what happens if copper conductors touch? We create something that we call short. Right? Now, stranded wire. Well, a bundle of small gauge wires. Gauge talks about thickness of the wire. So here's one strand of a bigger gauge, and over here we have a bundle of small gauge wires, right, insulated with non-conductive material. Right. Okay, usage. Usage. Household and commercial installations. And this one also has household and commercial installations. Can you install either of those within a household or commercial installations? Yes. except this one here is a little bit more expensive to produce, so it costs more. So within a household and commercial, this is the solid core wire is the preference, takes the preference. Right? For permanently mounted installations, it can also be used for okay. Now, typical in-wall power cabling, typical household or commercial in-wall power cabling. Now, here's where the difference begins. Stranded, that's where things are being changing. That's where things are changing here. Moving or vibrating parts, typical industrial equipment cabling. It has to do with something like this. If you installed a solid core wire on some machine that has motors running, things moving, a lot of vibrations are happening within the machine. The vibrations carried through the solid core better than through the stranded wire. So it is better to install stranded wire because the vibrations are not being conducted. We don't want to carry the vibrations through the wire, because what happens if vibrations carry through the wire? Well, some of the connectors might become undone. So if you pop the hood of the car, you're not going to see any solid wire connections. Pretty much all the wires that you're going to see are going to be stranded core wires or stranded wires. And then we have the advantages or disadvantages. Okay, well, this solid core wire is less expensive to produce. It has more compact diameter for the same current carrying capability as stranded. So, of course, what this means is that in order to achieve the same ampacity, and ampacity is the ability to carry a certain amount of current. So in order to achieve the same ampacity or the ability to carry a certain amount of current, you need to have a certain amount of copper. And you also have to have the same amount of copper. But you see, this here is more compact, so it's going to take less volume than the stranded wire, because you see those gaps between all that stuff. It's just going to take a little bit more volume. That's why when you have the wire strippers, you have two grooves for each gauge. So you will have, like, the stuff that we use is mostly gauge 14. So you're going to have a groove that says 14 solid and 14 stranded on your strippers. Okay. And of course, the stranded groove is going to be slightly bigger. Less likely to, okay, so this one here, this solid core wire is less likely to fail due to corrosion. Why is that? Well, it only has certain amount of area exposed to the elements to react with the air, moisture, and whatnot. Over here, in total, way more area is exposed, because each single strand is exposed, so it's almost like cut through, and it's kind of in stripes. So way more of the copper is exposed by volume to the elements. So this will corrode quicker than that. Now, let's look at the advantages of the stranded. It's flexible and withstands greater amount of flexing and vibration. That's important. In the industrial environment, where machines are connected and powered, you're going to pretty much see the stranded cable all over the place, all day long. Okay. So it's flexible, way more flexible than the solid, and sometimes you need that flexibility. and it's easier to route. Well, okay, easier to install because it's more flexible. Right? Now let's take a look at the disadvantages. Here, solid core, typically only available in small gauges. Small gauge means greater number. Okay. Gauge 14 is uh, gauge 14 and gauge 12, for example, which is thicker. Gauge 12 is thicker. It has smaller number, so it's thicker. Okay. So as the thickness of the wire of the conductor goes up, after a while, we don't have a wire anymore. We just have a solid metal rod. And it's not very practical to band, route, and install. So it can only be so thick in order to be practical. With some exceptions, of course, there's always exceptions, but we're talking generally. Continuous flexing or vibration will cause the wire to fatigue and break because it is not as flexible as the stranded, of course. Now, the disadvantages of the stranded cable or conductor. Diameter is larger than the same carrying capability. That's what we were talking about. It's because it takes less volume physically to accommodate the same amount of copper for certain gauge or for certain ampacity. Okay? More costly to produce, and manufacturing process is more complex. So there's the cost involved. And what's the other disadvantage of that? More likely to fail due to corrosion. Okay? So we talked about that too. So now I'm going to leave you with this here as far as this slide. Wire homes, wire. So just read through this here, and we're going to have a little discussion when we see each other in person as far as this thing here. Okay, as a kind of retention of the knowledge. Now, let's go and start about household wiring cables. Some of us already have participated in the first lab, and some of us are still going to do this week. So to some of us, what I'm going to say, it's going to be, some of the elements might sound like a repetition, but I'm going to repeat certain concepts because it's just the way I find this type of teaching more effective than just saying something once. Okay, let's not get into it. I digress here. All right. What do we see here? We see something that says 14.2. How many physical conductors do we have in this 14.2 cable? Right. A cable is an enclosed entity that encloses conductors, single conductors. We have one white wire, we have one bare copper wire, and we have one hot wire, black. White is always neutral. Bare copper is always ground or bond. And as a review from some of us who already participated in the first lab, what is the difference between grounding and bonding? The difference between grounding and bonding electrically should not matter. However, how it's physically arranged, that's where the difference is. If a terminal or whatever connector or whatever it is grounded, that means that from that point, there is an uninterrupted wire going straight to a true ground. It doesn't go through any other connectors. So that means that terminal is grounded. If the terminal is also grounded, but it hits another connector first and then it's joined to the ground, then yes, technically it is grounded, but in the industry, we are calling it as bonded. All right, so you're going to hear me using the grounding and bonding terminology interchangeably, okay? So out of these three physical conductors, two of those are considered current carrying conductors. And let's get that concept here. I am going to, do I have it? Yes, I do. A new updated version of my Photoshop. Let's change the colors. Okay, so let's say there is a, no, I want a pencil. Thank you. Let's say, let's make it thicker. Got it. Huh? That's what we want. All right, so let's say we have one conductor that is hot. We have one conductor that is neutral. And of course, we have a bonding terminal or grounding terminal. And those are connected to certain terminals that are supplying power. Yeah, terminal, terminal, terminal. Zoom in a little bit. Okay, so this, for example, this hot one here, this would be black and neutral is going to be white. White is always neutral, bare copper is always bond or ground, and the other one is hot. So let's say we're going to power up this light bulb here. There's a symbol of a light bulb. So we're going to run cables or conductors in order to power up the light bulb. Do we have a closed circuit here? Yes, we have a closed loop. We can, we leave from here, we go through the load, and we come back on the neutral. Of course, because it's AC, it's not like one direction of a current going, because there will be a DC type of a current. The current goes back and forth, back and forth. But just to make things simpler, let's just say that the current leaves hot terminal and comes back on neutral, just so we could get a better understanding of what a closed loop is. What else do we have? We have a bonding wire or grounding wire, my pencil, and that here is going to be connected to the chassis of whatever the light bulb is mounted on. If the chassis is metal. If it's a duplex receptacle, it could be a utility box that's made of metal, right? So out of these three conductors, the hot, the neutral, and the ground, these two are considered something that's called current carrying conductors. Because under normal conditions, they are supposed to carry the current. This one here is not a current carrying conductor under normal operation conditions. It is supposed to take the hit if something goes wrong, so you don't have to take the hit. It takes it, it absorbs it. Like, for example, if this hot terminal detaches from this light bulb terminal, and by accident it touches the metal chassis. If this metal chassis was just floating in the air, not connected to ground, it would become hot. If you touched that, and if you complete the loop to the ground, through your feet or through any part of your body, the current will flow to the ground through your body. But because we have this this grounding or bonding conductor permanently connected to the chassis, if that thing deattaches, if this hot wire detaches from the terminal here and touches the chassis by accident, the current will flow through the ground through this conductor right here. So it's like a safety conductor. And of course, what's going to happen if you have a circuit breaker in the electrical panel, it's going to sense too much current, it's going to open. It's going to disconnect the power to this circuit. So we have physically three conductors: hot, neutral, and the bonding conductor or grounding. But only two of those are considered to be current carrying conductors. So that's why we call this 14-2. Where does the 14 come from? The 14 comes from the gauge of the wire. So if you see a wire that says 14-2, that means it has two current carrying conductors. The bare copper safety wire is not, or the ground wire is not counted. So that's why we have a cable that encloses 14 gauge wires, which means the thickness of the wire, and it has two current carrying conductors. Now this one here, I'm going to go quicker through that. It's a 3-wire cable, so 14-3. What do we have? We have always neutral. We're going to have the bonding wire, and we're going to have two hot wires. One is black, one is red. Okay. Different other types of cables that are commonly used would be the armored cables. There's 2-wire armored cable, there's 3-wire armored cable, and sometimes they include bonds, sometimes they don't. Right? So I always got to make sure. It's also called BX. The X stands for experimental cable. When that cable was developed, it was some sort of an experimental cable that somebody was trying to, I'm not sure what company it was. So they call it the experimental cable. So that's where the X comes from. And the B comes from the second attempt of coming up with that type of a cable. So it's a BX. Here's the mystery about what the BX is, right? Sometimes you're going to see underfeeder cables for different applications. So underground feeder, and those can be also specified to be able to for direct burial. Okay, so you can just run this cable, but of course, every cable has their own uses and specifications. Accordingly, we're going to deal with different fasteners, and the fastener would be like, for example, here's one right here. That's the interface between the box and the outside world. So the cable is just not floating loosely in the opening that that leads to the box. All right. So different type of cables are going to employ different type of fasteners. We're going to, as we go along and use them, we're going to keep naming them. All right. All right. Gauges. As I was saying, the number goes down, the cable becomes thicker. Yes. They're inversely proportional. Number goes up, the cable is less thick. It's thinner. More number, less cable. Less number, more cable. Okay? I can remember it like that. All right. We're also going to be dealing with some single conductor wires, and see, just this part here, we already talked about the difference between solid and stranded conductors. And by the way, here in North America, when it comes to bonding or grounding, we're going to use bare copper wire or green jacketed wire. So this looks like it's a bonding wire. This looks like it's one of the hot wires because it's not white. Now, multi-conductor cables. We're going to talk about, and basically, for the most part, the cable that we're going to use is called, my pencil. It's called NMD90. All right. The NM stands for non-metallic, the D stands for dry, and 90 stands for 90 degrees Celsius. So it's non-metallic jacketing. It's supposed to be installed on non-metallic surfaces. However, with some exception, you cannot directly install this thing on steel studs, on steel framing. But if you run a pipe, a conduit, you can put that inside a conduit. Right? So that's where the non-metallic stands for. Non-metallic, dry. We can't bury that cable in the ground, or we can have this thing exposed to the elements. And 90, it's spec'd to withstand 90 degrees Celsius. Just put it in brackets because that's not being specified here. It's just NMD90. And sometimes you're going to hear that Romex, right? That's because some time ago, Romex was the only company that used to produce those cables. So that's why people call them Romex. Now, well, everybody and their brother produces that. So that's what we're calling it, an MD90, non-metallic dry, 90 degrees. So we have an example here of, what do we have? A neutral wire, we have a hot wire, and we have a grounding wire or bonding wire. And this is the gauge 12. So it's thicker than gauge 14. And well, has two current carrying conductors. So we are going to call this 12-2, even though it has 1, 2, 3 physical conductors there, but only 2 of those are considered current carrying conductors. Over here, this one here, 14-3. How many current carrying conductors? 1, 2, 3. One neutral, one hot for one type of circuit, another hot for another circuit, and we got the not counted bare copper wire, which is the grounding wire or bonding wire. So these conductors are the thickness of gauge 14, and there are 3 current carrying conductors plus the safety. Now, here's a larger appliance cable. Notice that we are switching from solid to stranded already because the gauge becomes thicker. The cable becomes way less flexible, so some of the preferences are going to be that the thicker cables are going to be stranded, as we were talking about. Right now, here is the BX cable, armored cable as well. Now, what do we have here? We have 2 current carrying conductors and 1 green jacketed wire. So this is going to be the grounded wire. Here's the neutral because it's always neutral is white. And here's the black hot. And of course, sometimes it's called MC armor cable, metal clad. MCBX armor cable. That's the terminology. Now let's take a look at the gauges. How do they compare? Common wire sizes. AWG stands for American Wiring Gauge. You can click to see the tool for measuring that. Just a kind of a sidekick thing that I did. I always throw things like that. Gauges, you see here, the gauge goes up, the number goes up, the wire goes thinner. And notice that the solid core gauges are pretty much mostly up to gauge 10 or down to gauge 10. Later, when the wire becomes thicker, it's just more practical for that thing to be stranded for the ease of maneuverability, I would say, if you will. All right, we got some reading here. The most common type of cable that's used in the houses is technically known as NMD90. So that's what we're talking about, and non-metallic dry service cable. What does that mean? Service cable is a cable that provides power, as opposed to what else could be? Well, you could have some signal wires, microphone wires, data wires. They they provide some sort of a signal, but they're not specified to provide power. So that's where the service cable. So NMD90 non-metallic dry service cable rated at maximum of 90 degrees Celsius. And I was talking to you about the Romex already. The cable is usually configured in 2 or 3 conductors. So you could have, 2 or 3 current carrying conductors. And depending on where you would install this thing, if it's like a living room duplex receptacle, you could just have 14 too. But if it's a kitchen wire, kitchen close to countertop receptacle, you might want to up the gauge, and you might want to have more cables, conductors in the cable, so you can do the split receptacle. We'll talk about that later, why we do that. All right. So let's just say the cable is usually configured a 2 or 3 conductor combination, 2 conductor having a black and white. We talked about that conductor, and a bare copper wire. Right, so that would be, let's say, for example, 14-2 or 12-2. The bare copper wire is never counted. Okay, we talked about that. 3 conductors has a black, red, and white conductor, and the bare copper wire. All right, the conductors are most commonly used in the household configuration or mostly commercial. Excuse me. Is going to be 14 gauge or 12 gauge. Notice that I'm not reading AWG. When I see that, I just substitute that with the word gauge. So the sentence would sound like this. The conductors are mostly commonly 14 gauge. Okay, the conductors are most commonly 14 gauge. Okay, the cable also comes with the 2 or 3 wire of 12 gauge configuration. So sometimes we need a thicker wire because we need more what? Ampacity. Why is there a paper? Yeah, sometimes we have the paper sheeting for different type of cushioning and whatnot, depending on who is making it and whatever reasoning they have behind it. So sometimes you're going to have the paper inside, sometimes you won't, depending on who produces that and what the reasoning is behind it. Yeah. All right, the most common type of cable used in houses is technically NMD90. Did we just? Yeah, we did that. All right, most commonly used cables and thickness uses. All right, so here's 14.2. Right? Mostly used for regular plugs, switches, lights. It is the 14.2. It's pretty much 70% of household wiring. Yeah? Now we have, so that's what it looks like, of course, 14.2. Now, 3 conductors, 14.3. It's used mostly for 3-way switches and split receptacles. We will talk about what a split receptacle is later on. And we are going to actually study what a three-way switch is. And once you figure out what three-way switch is, then four-way switch should be four-way switch system should be easy as pie for you. It might look intimidating right now, but please don't worry. I'll hold your hand and walk you step by step through the whole process, and you'll be satisfied with the knowledge that you have after you go through my classes. Now, here's as opposed to 14 gauge, we got 12 gauge. So 212. That means the gauge number is lower, which means the cable is thicker, which means it can carry more amps. So now we're talking about something instead of like a plugging in just a TV or a fan or something. Okay, here's a selected heaters. So some heaters might require 12 gauge wire. Air compressors, air compressors, anything that uses maximum of 20 amps, as well as kitchen receptacle circuits. The gauge 14 is specified for 15 amps. It's not saying here, but I'm telling you. So gauge 14, it's not as thick as gauge 12. It's specified for 15 amps, 1.5. Now here, gauge 12 is a thicker wire. It's specified for 20 amps. Why do we need more amps for kitchen receptacles? Well, the reasoning behind that is that if you have a receptacle in the living room or a bedroom, what do you have plugged in there? A clock radio, a lamp, a TV. They might draw maybe 2 or 3 amps or whatnot. Okay. Now, kitchen countertops are the most used in the morning. The whole family wakes up. There's a tea kettle going. There's a toaster going. There's some other toaster going. There's a coffee maker going. There's da 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 da. It loads up the circuit. So that's why there's a tendency of upping the gauge and upping the ampacity for kitchen receptacle units. Plus, instead of having one duplex receptacle, which means the two receptacles act as one, we are going to separate them by removing the tabs on the side so that each screw, the screw terminal, is powering up individual receptacle. And to one of them, you're going to run the black wire, which is one of the hot, and it goes to a separate circuit breaker in the panel. And to the other one, you can apply the red wire, and that can go to another separate receptacle, and they can be both 20 amps. So, they can service a lot of amps. So not only the wire has to be, well, if you want to up the ampacity, it's not enough just to replace the circuit breaker for a bigger one. You also have to consider the gauge of the wiring. Otherwise, you can seriously, and this, you seriously can start a fire. Because if you run more amps through the wire that it's designed to, it heats up pretty quick. Right? I got a question here. So if you want a new 30 amp plug in your home, you need to use a 3-conductor 10. Let's get to this thing here. Yep, there you go. 3-conductor 10 watts, so 310 or 10-3. Right? Any device that requires sorry. Any device that requires 30 amps, and that will be typically like an electric dryer. Right? Now, we're going up with the gauge. Look, gauge number 8, 3 conductors, maximum of 40 amps, and most applications will be your electric wrench. Electric wrench is basically electric stove. It takes a lot of amps. Right. Here's a question. Typically, household wiring is done in series, in parallel, depends upon the color, or using a dummy way, the easy way. Any answers of how the household wiring would be wired in series or in parallel? If you have a branch, we got 1B, we got 1A, and the others, we just need C and D. I'm gonna complete the whole spectrum. All right, let me get to this here. Nope. Yeah. All right. So let's see, we have the hot, neutral, and ground power supply. Where's my pencil? Here it is. Here's a duplex receptacle. Here's a duplex receptacle. Here's a duplex receptacle. Okay. If we connected them in series, it would look like this. Like that, like that, and like that. Okay. So let's say we have a TV plugged into this one here. Here's a fridge. And over here is oh no, let's say here is a vacuum cleaner. All right. And here is a fridge. Now, in order for the circuit to work, all of them will have to be plugged in. So if you don't have the TV on, and if you don't have the vacuum cleaner going, the fridge would not work because the loop would not be closed. So that's not a practical way of connecting the household wiring. All right. Now we connect them in parallel. Let's see here. Here's an outlet. Here's an outlet. Here's an outlet. Okay. We connect them like this. That will be a parallel connection. So each an individual circuit, once you plug in, it's going to complete the loop on its own. Right? So that's why the winner is B. Okay. Now, I'm going to leave you with this picture, and I'm going to ask you to read that and see if we can find Waldo here, quote unquote. Now, one more thing before we leave. We're almost done. Service conductors. Remember, when we're talking about service, that means these are the conductors that provide power. And by the way, whoever came up with an answer, thank you for being brave. And I don't want you to be afraid to answer anything. Even if your answer is wrong, it's still good to me because I see you're paying attention. All right. All right. Service conductors. These are conductors that provide power. Remember? All right, let's read this sentence here. There are specific cables used to carry power into the house to the service panel. These are the cables that are coming from outside. These are referred as service conductors. Service conductors that are run overhead, because some of them are underground, but the one that run overhead are generally made out of aluminum, or in UK would say aluminium. And the reason for that is to reduce the weight. Of course, copper is a better material for service conductors, but aluminum is not as heavy. So that's why To reduce the weight, aluminum cables are used to provide the service if the cables are run overhead. It might be on a test. Okay, guys and girls, this is it for today. We're going to carry on with the concept of probably portable conductors, portable cables, when we see each other tomorrow in person. And if you have any questions, write it down and ask me tomorrow. And I have to set up for same class 10 minutes from now. Thank you for your attention, and I'll see you when I see you.